Thanks, Chris. So last time we were here talking about OpenConfig was back at NANOG 64, 2015. Glad to say the project has survived until now and grown. So wanted to give the community an update on sort of where we are. I don't have time to talk about everything that's going on, but wanted to highlight a few things. So you may know or recall that OpenConfig started with a real focus on building data models for the management plane. So the goal here was to define a set of vendor-neutral APIs, ultimately, that we could use to manage across heterogeneous networks. I think many of us in the operator community are looking for always introducing best-of-breed technology, regardless of vendor, and having sort of the issue of integration with all the different proprietary CLIs or APIs and so on that are being produced by our innovative vendor community. We'd really like the management plane to be simple and easy to integrate. So data models was the first focus, and when we were here last time, we had a handful of models that were not really yet implemented. Glad to say there's a lot of progress that I'll talk more about later. The other sort of main focus area, which we also talked about last time, was this notion of streaming telemetry. So the idea here is really to change fundamentally the way we do network monitoring. So moving from SNMP, which has a bunch of limitations that we talked a lot about last time in terms of scalability, archaic implementations, also proprietary extensions from various vendor platforms, to something that again is more uniform, more real-time, more scalable, that gives us data at a much finer granularity. So we've flipped the model into sort of a push rather than pull model, and also data being exported using the same data models that we're defining here on the left, gives us a normalized view of all of the data in the management plane on a device. So that's another sort of secondary focus area for the project. And then most recently, we've sort of turned our attention to kind of enabling people to more easily consume and use these models, right? So we put a lot of focus on actually building a device interaction layer that again normalizes the way that you can talk to a device from a management and configuration and monitoring point of view. So rather than having, let's say, different versions of netconf across platforms or restconf, which all do slightly different things, using a somewhat outdated mechanism and a fairly inefficient encoding on the wire, we looked for an opportunity to really change the way that interaction works. So a more scalable protocol for the RPC built on standards like HTTP2. I'll talk a little bit more about gRPC and GNMI in a little bit. But we think the advantages are significant over some of the existing protocols today. I will say, though, that from an OpenConfig community perspective or group perspective, we're not really taking a position that we have an official RPC mechanism. So the operators in the group continue to use a variety of different protocols to talk to devices. But one of the new things that's come out of the work of some of the folks in the community is a new RPC mechanism. And of course, a bunch of tools that help turn models into code that makes it much easier to interact with them. Our list of participants has grown quite a bit since we were here last time. I think we're up to close to 20 participants. In my rush to change all these logos into text per NANOG policies, I actually left off Cloudflare and Mirchau. Don't want to forget him because although relatively new, they've been a great contributor and have already proposed a bunch of new models that really take us forward. So let's talk a little bit about what kind of coverage we have in terms of data models. So we're actually reaching a point now where we think we have reasonable coverage across the configuration space with a few notable gaps that we're still working on. In particular, if you take a look at the network instance model shown here, this is where all the routing protocols live, things like VRFs, FIB, RIB, route redistribution policies, all of that stuff goes through the network instance, including things like VLANs and MPLS, segment routing, et cetera. So we have a lot of capability sort of bundled up in this notion of a network instance from an L3 protocols perspective. And then aside that, we have the routing policy model. So these are sort of the kind of basis for the routing capability in the models. We have a fairly extensive interfaces model, although we don't try to be exhaustive in our models, as you may know. We actually focus on things that are operationally useful and needed. So we don't ever add something to the model until there's an actual use case for it and that there's implementations of it. So platforms need to implement it. We don't want to sort of create pie-in-the-sky features that don't really have implementations. So interfaces have all the things you'd expect in terms of IP, Ethernet, aggregates, and then sort of this other half of this picture There's various L2 protocols, there's system management. We have a section of the model called platform that's really intended to capture some of the hardware-specific parts of a platform. So there may be some platform-specific modules that has some associated data. That stuff gets put in the platform model. You can see in red one of the gaps that we're still working towards is the QoS model. This is indeed a gap we've been working on for a while, but I think we're pretty close to publishing a draft that we can then get feedback from both the operator and the vendor community. Some newer areas that we've gone into, optical transport. We've built a fairly complete optical transport data model now around both transponders, muxponders on the terminal optics side, as well as amplifiers and ROADMs on the line system side. Things like channel monitors, automatic protection switching is all part of that. Most recently, we started a new sub-project around Wi-Fi that is actually modeling access points both at the physical layer and the MAC layer. So with the same goal of sort of normalizing the API that we use to manage and monitor Wi-Fi devices. So one of the things that we've really focused on in the last maybe year is how to actually enable the community to use Yang models. We've found that operators and engineers who are trying to write automation don't actually care about the modeling language at all, right? They care about the code artifacts that they need to use to produce configuration. So we try as much as we can to hide the fact that we're using Yang models in this, even though they are fundamental in terms of our ability to interoperate and work with vendors and so on. So we have a tool chain. We kind of developed this sort of two-pronged tool chain in Python and in Go. Starting with OpenConfig models, we have these tools that do model validation. Pyang is actually not an OpenConfig tool. It's an open source tool that those of you who work with Yang models I'm sure know and maybe not necessarily love. And then we've built another one, a validator compiler called GoYang that's sort of a Go tool chain for doing the same sorts of things. We have two different ways to do code generation. Pyang bind for Python classes, YGOT, stands for Yang Go Tools, produces either a set of Go structures that you can fill in or also protobufs that you can manipulate directly. And then what you do with your code is that once you've generated these code artifacts using the models that you need, you can populate either these structures, these Python classes or protobuf instances, create an instance of configuration data, and then validate it and serialize it to JSON or to protobuf. So we have sort of an end-to-end tool chain that lets you do this to build configuration data out of Yang models. The other thing we've been working on is RPCs, as I mentioned before. So our focus has been quite a bit on what we call the gRPC network management interface. It's basically an alternative that's been implemented to things like netconf and restconf. The difference with maybe other protocols that you've seen is that it bundles both the configuration management as well as monitoring into a single service for basically all of your state management. It's a very simple service definition. It's only got 4 RPCs in it. You know, it's one thing to get a set of capabilities, what version it's running, what models the device supports, an RPC to get snapshots of state from the device, an RPC to manipulate state on the device, so this is configuration in the set RPC, and then sort of one of the key ones is this subscribe RPC, which is a streaming RPC that lets you subscribe to telemetry notification streams on the device based on the Yang model. So you specify a path in the data tree that you want to subscribe to, you issue this subscribe command, and you either get data periodically or on an on-change basis, depending on the type of data. So we have actually multiple implementations of GNMI, not quite shipping yet. Most of these are in early release images that are available to you if you ask. And importantly, both on routing platforms as well as optical transport platforms. So we're looking at GNMI across the board as far as device types. Where are we on vendor implementations in general? So we've had a lot of steady progress on building support, native support on target devices for the data models. In particular, the first set of models we worked on were like BGP interfaces, routing policy, also terminal optics. These all have implementations now that are either shipping in available code or in early release implementations that you can get. And there's a bunch of other models that are in early release code that you can get for testing. On the streaming telemetry side, there's actually shipping capability from multiple vendors at this point. In our case, we've actually deployed streaming telemetry in production. We're very close, down to the last 1% of data for being able to deprecate SNMP completely in our network, at least for one of our platforms. And we're pretty close on others as well. So the vendors that are participating kind of actively, that have shipping or early release code, include the ones that are mentioned here. This has been a really great partnership with all of the vendors. I think lots of support industry-wide to sort of make this happen. And then finally, to wrap up, what else is coming from OpenConfig? So obviously, we have a few gaps in the models that we're working on. New gaps will keep coming up as people bring new use cases. In particular, we're working on traffic engineering policies for segment routing, QoS, as I mentioned, a model for probes that Mircea has actually been pushing, BFD, flow sampling, a few other things. On the streaming telemetry side, I think we continue to work with vendors to increase the coverage of what's available via streaming. And then we're also starting to work on actually converting the stream into something that's OpenConfig compliant, which means that it follows the OpenConfig data model so the data looks the same across platforms. We continue to work on RPCs and tools. In particular, we started turning our attention to not just the configuration management, but also operational commands, and trying to figure out if we can normalize the way operational commands are executed on devices in terms of the parameters that you set and the data that you get back. And we're looking for updates to how we interact with the community and a bunch of new native implementations that are in the works. We actually spend about 2/3 of our time working with vendors to expand and improve the model coverage on devices. So I'll stop there and see if there's any questions.
We have time for one quick question.
Philip Matthews. I tried actually asking this question yesterday in the larger tutorial, but didn't get a good answer, so I'm going to try again. What happens if the underlying device has a view of the world that's different than OpenConfig's? I mean, in past, we haven't tried to standardize CLI or anything like that. It's all been sort of seen as, something that vendors can do differently. And this seems to be sort of an attempt to standardize now the inner workings of the box, as opposed to simply the communication outside the box. So if OpenConfig says this thing here should just come in white and yellow, and the vendor has something that is in brown and black or something like that, then what happens?
Yeah, so this is essentially a mapping exercise, right? So all vendor devices have their own native ways of representing various kinds of data and different ways to format things and organize data. So what this becomes is essentially taking the OpenConfig model. So we design the models from an operator perspective. What makes the most sense from an operational perspective? This is why the group is primarily users. And then we work with vendors on how does this map to your configuration and backend data structures. In some cases, we actually change the model based on vendor feedback because something we did maybe doesn't make sense. So it gets a little bit closer to one vendor's world, but departs further from another vendor. So there's no sort of it's a bit zero-sum in the sense that what makes it easy for one may make it harder for others. So there may be more mapping work to be done on one platform. But the way we're getting around this is that most vendors have built mapping or translation layers. I think some vendors have invested a lot in that to support external models more generally. So I think there is some impedance matching that needs to be done. It's not going to happen in one release overnight. I think we gradually are seeing more conformance with the OpenConfig model, but on day one, you typically don't have everything there.
So I'm just thinking, one of the reasons the IETF has never tried to standardize something inside the box, this was seen as a way of differentiate and improvement. And this seems now to be trying to go inside the box and standardize it.
I disagree, actually. I mean, I think what we're trying to standardize is just the management plane interface. I think if you're a vendor and you're really trying to differentiate on the way I issue CLIs or the way I call my BGP variables in this platform versus that, that's probably the wrong focus. We're just trying to simplify the integration of all the upstream automation tools that we're building to be able to talk to the devices. So I think there's still a lot of room for vendors to innovate on the core capabilities of their device in terms of the quality, power consumption, density, speeds and feeds, all of those things that they would typically try to differentiate on.
We're going to have to cut off questions, unfortunately, at this point, but thank you.
Thank you.